Thanks, everyone. This is an awesome turnout for the early morning talk on the last day of the conference. How many people had a late night yesterday? Yeah, well, thanks for waking up early. I hope everyone had their coffee, but if not, we're going to be talking about something really exciting today, and I'm really excited to present a lot of work that my team's been doing over the past 2 to 3 years. And this week we announced a early beta of our open source security as code framework. And today's talk is really going to be about our journey in building this framework over the past several years. We'll walk through some of the design decisions we made, some of the lessons learned along the way, as well as kind of talking about the overall problem that we're trying to solve for and why we believe this is the right approach to solve that problem. So I'll jump in, but before I do, quick disclaimer. RSA likes to make sure that the legalese is taken care of. But let's start with the context. So software delivery has completely transformed over the last 10 years, and I think everyone here knows this. 10 years ago, the teams that I worked with, there were 2 different teams involved in delivering software. You had your app dev teams and your infrastructure teams, and they were pretty siloed. Today, infrastructure is designed and delivered as code. And increasingly, this infrastructure is now falling under the umbrella of software development. And so all of the best practices that we've learned around agile software development are now being applied to infrastructure as code that's being written in languages like Terraform, CloudFormation, Kubernetes manifests. And because of this, developers are now able to deliver infrastructure in an agile, iterative manner. We are able to make changes to infrastructure at a rapid pace today. And it's giving developers incredible velocity. And what we're seeing because of this is entire application architectures and even environments in the cloud are now defined in entirely codified in languages like Terraform. And what that does is it makes these architectures dynamic. They're changing on a day-to-day basis, on a sprint-to-sprint basis. And so this makes security's job really hard. And so I'll talk about some of the trends that then this leads to that really creates challenges for security. So in your organizations, if you were to measure the entropy of your cloud architectures over the course of your cloud journey, and you were to measure the entropy in terms of the interconnectedness of the components of your architecture, what you would see over the course of your cloud adoption journey is an exponential curve. We are building cloud architectures at an incredible scale and complexity today. And fundamentally, that complexity and scale creates a very dynamic and large attack surface for security to deal with. The other major trend is that we are able to make very rapid, fast, frequent changes to these architectures. So what I'm showing here in this chart is data from our own platform's infrastructure as code repo and how rapidly my team makes changes to this architecture on a day-to-day basis. And so on average, you'll notice that we're making 5 to 10 changes a day to that architecture. But when we have major features that we're releasing, that spikes up. And when major features are being released, that changes from 10 times a day to 30 times a day to 40 times a day. And when you're operating at this velocity and this rate of change, it's really hard for security to be engaged in every decision that's being made as developers are defining these architectures in code and making changes to these architectures in code. It becomes very hard for security to keep up and really assess every change, to provide guidance on every change, to make sure that we are considering the business requirements around security as these architectural changes are happening. The other major trend is that cloud service providers are also rapidly iterating over their feature capabilities. And so on a daily basis, the large cloud service providers like AWS, Azure, GCP, they make changes to every single one of their feature capabilities. And as they change rapidly, and we know developers love to use the latest and greatest features that are being released, it becomes really hard for security to keep up and maintain their knowledge base around, well, what are all the latest and greatest capabilities? How do I secure this? And when those changes are happening, and that's this trend of developer freedom, where developers really have the freedom to choose the architectures of their choice, to choose the cloud service providers of their choice, to choose the feature capabilities of their choice, then that just broadens the surface area that security needs to support. And that becomes really hard for small security teams to support. And that leads me to the other large trend that we're all aware of, which is there's just not enough security resources. This data is from a very old survey, but anecdotally, I can tell you that over my career, this has held true in almost every organization that I've been at. And there's almost never enough security engineers to scale to the size of the application portfolio, to the size of the development teams, and to the rate of change that these development teams are now driving. And so it is almost impossible for any security team, including big tech security teams, to really keep up and address the security design challenges and really kind of catch design changes early and help developers build more secure applications. And so what I want to talk about is, well, what does a modern security practice look like? I think we're all familiar with this paradigm shift. What does a modern security practice look like that can support this trend, that can allow security to really effectively partner with the rest of the organization, especially the development teams, and helping deliver applications and features that are secure by design, but then also deliver them at the same velocity and agility that the business is looking for. And so one of the, this is not an inclusive list, but in my opinion, these are kind of four major pillars of any modern security practice. One is you're going to look to democratize security. Given that there's only one security engineer for every 100 developers, right? We need to bring the developers into the tent. Developers need to be part of the solution, and we need to make security accessible to them. We need to make security open and transparent to them, and bringing them in and having shared responsibility with them is the only way we're going to solve this broader problem. The other major pillar of a modern security practice is that we embrace automation. We recognize that our manual, traditional workflows, paper-based workflows where we deliver Excel files with 50 requirements to the development team is just not going to scale. At the rate of change that they're making, at the rate of change that they're operating at, it's impossible for us to keep up that way. So we really need to embrace automation, and we need to be automation first. And then lastly, when I think about my journey in security, when I first joined the workforce, security practitioners were technicians. We were hardening operating systems, so that dates me a little bit. From there, we saw the rise of kind of compliance-focused security practices as laws passed, as regulations passed around security. And then those shifted into risk management-focused security practices, which a lot of organizations are still kind of at that stage of maturity. And then we shifted from risk management to really adding that business enablement component, and how can security enable the business? And in my opinion, right, a modern security practice needs to kind of take that next step in their evolution and really not just focus on business enablement, but security has to be at the table and has to share the same goals as the business. If the business wants to deliver features for their customers at velocity, if they want to take advantage of fleeting business opportunities, and so they want to build agile architectures that let them do that, we need to be able to support that. And so security needs to be a driver of that velocity. It needs to be a driver of that agility. And in order to do that, right, security really needs to focus on prevention and building best practices, catching things early as opposed to being reactive after things get deployed. And kind of the last major aspect of a modern security practice is culture. We need to create a culture that is collaborative. We need to break down the silos, and we need to have shared responsibility around security. Security risks are not just owned by security. Security risks are owned by the organization, and everyone that is responsible for building a product, building a feature, should share in that responsibility and should be involved in addressing the security goals that that business has. So that leads me to one of the core aspects of a modern security practice is the ability to then define security best practices as code. And this isn't coming from me. This is actually coming from the business consultants at McKinsey who understand this as well. and have written about this. And when we look at the size, scale, and complexity of these modern cloud architectures, the only way security teams can scale is by embracing automation. And part of that automation has to be being able to define security policies, security reference architectures as code. Being able to really look at what are the best practices and the architectural patterns that I want my developers to follow, and being able to codify them so that we are not engaged in firefighting on a project by project, on a decision by decision basis. So what is this talk about? So this talk is really about our journey in solving that problem. We noticed this problem many years ago, and we felt like we wanted to really invest in addressing this problem. And so we set out to build our own security as code solution. And this talk is really about our journey from where we started, the lessons that we learned along the way. And we started working on this in early 2020 when we released our first design, our MVP. We built our own security as code language for our internal use. And then, we realized we made some mistakes along the way. We pivoted from an architectural standpoint. We released an SDK and a framework in 2022. And my team was the first adopter of this security as code. And we build security reference architectures as code, so we codify reference architectures from NIST, Cloud Security Alliance, AWS, Azure, GCP. And now what we're doing, this week we announced an early beta release of a security as code framework called Tython. And what this framework is we've taken kind of the core elements of our internal framework, and we're starting to open that up to the community. And I'll talk a little bit more about that, but what I'll do in the rest of this talk is really take you through our design lifecycle. Our lifecycle from starting from, how did we view this problem? What were the requirements? What were some of the key design decisions we had to make along the way? And, what is the end result? And so I'll do a demo at the end, and I'll show you what we've built. All right. So I'll start by defining the problem. So this is what I wrote on a whiteboard 3 years ago, and I couldn't find the whiteboard picture. I know it's there somewhere on my phone, but I couldn't find it in time for this talk. But I'll read it out to you. So what are the primitives, the foundational primitives that we need to express an arbitrary security architecture, an arbitrary but reasonable security architecture, and assess an arbitrary but reasonable solution architecture against it? So I'll let you read this, and I'll parse this in a second. So what do I mean by this? So there's kind of two aspects to automating design validation and really allowing security to automatically assess every design change that is happening. One aspect is we need to understand the solution architecture, but given the trends that we talked about, we cannot make any assumptions about what the solution architecture is going to be. That solution architecture is changing on a day-by-day, on an hour-by-hour basis, and so we need to understand that what we're going to be presented as security practitioners is an arbitrary solution architecture that someone has built. Now, I added the caveat that this is reasonable because we're going to expect that developers aren't going to do just completely crazy things and mix and match architectural components in some random way that doesn't actually work. So as long as we assume that what they're trying to build is a working solution architecture, then we should assume that we're going to get some arbitrary solution architecture, and we need capabilities that allow us to get visibility into that solution architecture. And that's what our company focuses on, is we've built a platform that lets us get visibility into that architecture as it's being written in infrastructure as code languages like Terraform, CloudFormation, Kubernetes Manifest, in the developer's IDE, as it gets committed to code repositories, as it kicks off pipelines, and as things get deployed in the cloud. And so at every stage of that life cycle, we can get visibility into this solution architecture. But what we inherently have to assume is this architecture is not static. It is going to change. And so we have to add that arbitrary tag to it. In the same way, then, from a security architecture standpoint, we need to allow security engineers the freedom to express an arbitrary security architecture. Every business is different. Every application architecture is different. Your requirements are different than mine. And so you need to be able to express a reference architecture that is tailored and unique to your organization. that fits the needs of your organization, that meets the business objectives that you have as an organization. And so what are those kind of core primitives that we can build and open up that would allow you to then express these arbitrary solution architectures and then use our platform to get visibility into the solution architecture so you can assess that solution architecture against your best practices, against your reference architectures. So what I'll do is I'll walk us through our design lifecycle, starting from requirements to design trade-offs, and where we ended up. So if I parse that statement and I kind of start breaking that down into categories of requirements, one of the first category of requirements is, well, then we need to be able to express these dynamic and comprehensive reference architectures. So what I mean by comprehensive is it needs to be able to express a pattern, a design pattern. It needs to be able to express complex interactions between multiple systems. It needs to be dynamic in the sense that any reference architecture, in order for it to be reusable, it needs to support a wide range of use cases. And so, we can't build custom reference architectures for every use case we encountered. Security can't scale that way. So can we build a reference architecture framework that allows us to express reference architectures that covers a category of kind of similar use cases, and we can then reuse that reference architecture over and over again, but tailor the feedback that the developer gets based on the use case that they're addressing. The second requirement then is, well, we need to be able to assess these solution architectures that are going to be arbitrary. We cannot make any presupposed assumptions about what the solution architecture is going to be, because when we empower developers to have freedom, they will choose the cloud service providers of their choice. They will choose the feature capabilities of their choice. So they will build a pattern that fits their needs, that solves the customer problem that they're trying to solve, and we need to fit into their workflow as opposed to dictating exactly what patterns they should be following. And in order for us to democratize security, in order for us to involve the developers and security engineers, not all security engineers are used to writing code. And when we want to make this accessible to everyone, it needs to be easy to use, it needs to be accessible, and it needs to create transparency both for developers and security engineers as to what patterns we want to follow as an organization. And then lastly, this needs to be simple and extensible. As an open source project, right, we want this to be very simple and extensible so that others can collaborate with us and help us build kind of the next iteration of this. So as with any good design process, then we started by defining our guiding principles. How are we going to make decisions in this space as we design new capabilities? What are kind of our key drivers here? And so we talked about simplicity. We want to make sure that as we make design decisions that we want to enable autonomy for both development and security. And so the first users of this framework was my team. And our big goal was to make sure that my team can operate independently of the dev team that's building the platform, so that we could operate at our own velocity. We could continue building reference architectures and best practices, but at the same time allow development teams to operate at their velocity, but then collaborate more effectively with them. This is all about adding value to the end user. There's no point building something very sophisticated and fancy if it's not going to add value to the end user. And so every decision we've made along the way, we've tested that from that perspective. Reusability. Can we build reference architectures that are reusable, that allows security engineering teams to then really focus on doing the strategic work of building design patterns and reference architectures and reuse them over and over again? Can we support this? Can our users support this when they adopt this within their own organizations? And will this drive the transparency that we're looking for in terms of what are the expectations that security has for this development team? If the developer can see the reference architecture, it's defined in code, it exists in their own code repository, then they can actually look at that reference architecture, understand what security expects of them. And if they don't like the reference architecture, they can propose a code change. They can create a PR and then tag the security team to say, hey, I actually think this needs to be designed differently. Here's my suggestion to it. So it allows for transparency and better collaboration. Along with that, as a business, we have a variety of considerations. as we invested in this solution. So, for us, cost is obviously a big consideration. What is the work, effort, and time required to actually build this? How will we support and maintain this as a small team? As well as kind of strategic considerations around, if we build this, will the community come? Will we get the collaboration from the security engineering and architecture community that we're looking for? What are everyone's cloud strategies and how are they shaping up? 3-4 years ago, everyone was talking about single cloud strategies. That pendulum has shifted now, and now everyone's talking about multi-cloud again. And so really, what are each of your organizations doing? What does your cloud strategy look like, and how can we fit into where the market is going in terms of the cloud strategies that organizations are adopting? And then licensing, right? How will we license this? How will we stay in business? How can we open source something but still, have a value-added product that's going to continue to generate revenue? So what I'm going to do now is really walk through a number of key design decisions that we had to make and the trade-offs that we weighed and the decisions that we ended up with. So build versus extend was one of the first decisions around, well, are we going to build our own, or there are other security as code languages. Can we build on top of it? Can we extend those? And in 2020, when we were looking at this space, we really felt like this paradigm shift was unique. Cloud architectures were really evolving at this rapid pace, where we felt like we needed to build useful abstractions that really masked the nitty-gritty complexity of this problem from the security engineering community. And so we started off by actually building our own custom language. And as with building any language, we were building our own parsers, our own expression trees to parse the expressions. And in the very early days, right, this is what those expressions looked like. And what's happening here is we're looking at a design preference around having sticky sessions for load balancers, and we're saying, okay, well, if we see any of these types of load balancers, let's make sure that sticky sessions are enabled. And I'm sure everyone's eyes are straining just reading this. It became more and more complex for us to express a lot of, to express the complexity of the reference architectures, these dynamic and comprehensive reference architectures that we wanted to build. And it violated some of the guiding principles that we set out to solve for. It was not simple. It was not easy to extend. As we did some user testing, we realized that users really had trouble expressing reference architectures as code in this language. And it was hard for us to support. Building your own compiler and your own parser, right, is very costly. It's engineering heavy. And it was hard for us to kind of continue to support new features and capabilities. And so very quickly, as we released this, we realized that we needed to really kind of change the direction that we had from an architecture standpoint. We then looked at, okay, well, let's extend an existing language. There are other security as code frameworks. These are some of them. I'm sure everyone's heard of Rego. Pulumi has a cross-guard framework. CloudFormation has its guard framework, and then HashiCorp has a Sentinel framework. And what we did is we built proofs of concepts for each of these languages to see, okay, can we do some of the things that we want to do using these languages as our backbone? And fundamentally, we ran into some challenges. The biggest challenge is, right, some of these languages are declarative, or more on the declarative side. And what that does is you don't have the full power of powerful data structures in order to express reference architectures that involve multiple components that are interacting. It didn't fit our requirements there. From a control flow standpoint, these languages were limited. And so we ended up having to really fit things, square pegs into round holes over and over again across most of these languages. In other cases, like Pulumi's CrossGuard, what we found is that it was very hard for us to build good abstractions on top of what was built. And it tightly coupled us to things that others were doing, which then created a situation where, as changes were happening to that open source project, it would be very hard for us to maintain and support. And then from a learning curve standpoint, then a lot of these languages have a very steep learning curve. And we talk about mean time to dopamine. We talk about, can you kind of get started within a half hour and build your first blueprint in a very easy easy-to-use way and release it, publish it, and start using it within your organization. And it didn't meet those requirements. And so that didn't fit our needs either. So then we started with, we looked at building our own framework and SDK. So why don't we just let developers and security engineers build these reference architectures in the languages of their choice? Let them build them in Python, Go, Rust. These are languages that they're familiar with. And then what we will do is provide a framework and SDK that provides those abstractions on top of it that lets them express these reference architectures as code, but use the power of a modern programming language. And that's the decision that we went with. And then it became imperative for us to then figure out, well, what is the language that we're going to support? And one of the key design decisions we made early is we said, okay, well, we really buy into this concept of developer freedom and security freedom. Like, security practitioners should be able to choose the tools that they want to use. They shouldn't be pigeonholed into one solution versus other. And in order to support that trend, we realized that what we really needed to do is build a bring your own language framework. So let you build these reference architectures in the languages that you're comfortable with, that you've trained with, that you are familiar with. And we will support each of those languages as we release a framework in SDK. And as we release Tython, the first language we're supporting is Python. In a few weeks, we'll release support for TypeScript. And then we'll continue adding more support in this open source project as we get the community more engaged and we get better feedback from the community. And the last major design consideration was when we think about, okay, we're going to get this arbitrary solution architecture that the developer is building. Well, what is this security reference architecture going to operate on? Does this reference architecture need to understand the nitty-gritty details of every technology? Do we need models to be specific to each technology that's being used, whether it's Elastic Load Balancer v2 versus Azure Load Balancer versus Google Load Balancer as an example? Do we need to understand the nitty-gritty details of each of them? And does the practitioner need to know this so that they can build the right best practices? And so one approach is to say, okay, well, we're going to be cloud-specific, technology-specific. And what that does is then your reference architectures become cloud-specific, and you have to build the same reference architecture over and over again for every common technology that your developer uses. So for example, AWS has many flavors of load balancers, and your developers may choose any of them. If you're a single cloud company, then now you have to build reference architectures for each of them. If you're multi-cloud, well, now your surface area grew even more. Now you have to build reference architectures, include the Azure Load Balancer, the Google Load Balancer, and so on and so forth. And so when we look at cloud-specific models, we felt like it wasn't addressing the trend that we were seeing in the market, which was more and more companies were becoming multi-cloud. And it was tightly coupling the solution and the reference architectures to the technologies that were being used. And for folks that are security architects in the audience that have kind of served that function, in order for us to build reusable patterns, right, it's often better to be at the conceptual level and really look at things in terms of load balancers, not Elastic Load Balancer versus Google Load Balancer. And so that led us down the path of, okay, well, let's do something cloud agnostic. Let's build this in a way that allows the security practitioner to really be agnostic to the cloud. And it goes back to that trend of, well, not every security engineer understands all of the different cloud feature capabilities. It's really hard to keep up. And so, but we understand load balancers, we understand databases, we understand message queues, we understand message brokers. Like we understand core technologies, but we don't know, we may or may not know the details of any given technology. And so maybe we can completely abstract that away and really focus on kind of core technologies that we need to help secure for our application architectures. So we went down this path as well. We built some proof of concepts. We tried to look at how can we do this in a true multi-cloud, cloud agnostic manner. Well, the challenge we ran into is that when we say load balancer, in the cloud world, load balancers are not all the same. They don't have the same feature capabilities. They're all called load balancers, but they actually have quite different implementations, quite different feature capabilities that they're offering back to the customer. And so what happens is across cloud service providers, whether if you take a managed database as an example, you can take DynamoDB in AWS as a managed database as a service. You can look at SQL database in Azure or Google, SQL database in Google. there are fundamental differences in the feature capabilities that they offer. They're not the same. They are databases as a service. They have a similar shared responsibility model, but that's the extent to which they're similar. There's just a lot of variations. And so that became a challenge. And the other trend that we were seeing is that more and more we're seeing these consolidated composite components. So it's not just a load balancer. It's a load balancer, but with an API gateway, with a firewall, with a CDN attached to it. So it's just one component. You can configure it all the same, and we're just going to offer that to you as a service. And so that would require us to then break up this component into various kind of technology components so we can build reference architectures for the load balancing piece of it, for the firewall piece of it, for the API gateway piece of it. And so that became challenge, and became quite a challenge, so we decided not to go down that route. And instead, we focused on building an abstracted SDK that lets you still build reusable reference architectures across a multi-cloud environment, but do so in a way that can still be cloud-specific, that allows you to still understand the nitty-gritty details of what's happening in a given cloud and a given technology, but abstract that away for most of your use cases so that your reference architectures become reusable. So here's where we ended up. And this is the architecture that we landed with. So what we built is an open source CLI and a framework. And, oh, sorry, wrong button. So there's kind of 3 commands that this CLI has, right? You can test locally. Once you install the framework, you can test your architecture locally. Maybe there's an infrastructure as code repo, for example, that is representing an application architecture for a project that you're supporting. And you can clone that repo. You can immediately test that locally in your environment. You can apply the reference architecture that you've built to that architecture and immediately get feedback. And so you can really focus on test-driven development approaches. And your developer can do this locally as they're building their reference architectures, as they're making changes. And they can get fast feedback from security without having to engage security in a true white glove model. So this becomes fully self-service for that developer. They can follow a test-driven development approach. And for every design change they make, they can immediately assess that against the reference architecture. They might find that, hey, we're violating a bunch of requirements that we needed to meet for this architecture because this needs to be FedRAMP compliant or it needs to be PCI compliant. And because of that, we place some very specific requirements on this architecture. So they get that fast feedback, and then they can decide, okay, well, actually, this isn't the right reference architecture for me. Let me go change it. And that becomes now an interesting point of collaboration with the security team, where now they can really focus on the design decisions for their application architecture and how they are taking an enterprise reference architecture and making it a security solution architecture for their particular solution architecture. And when you operate as code, you get all of the benefits of that. So you can very easily build enterprise reference architectures that kind of become your gold standard across all your application development teams. Developers can adopt those reference architectures and make them their security solution architectures. And now you can easily manage drift across these architectures. While I published version 1 of my enterprise reference architecture, I noticed that application team A adopted that. We've now released version 2. We want to bring those teams in line. And so now we can seamlessly start releasing that new reference architecture to that development team. They can start testing against it locally as they're making their next set of changes for the next release and immediately get feedback. And they have clarity on what is security requiring of them. And it is not a Jira ticket, an Excel document. They get the hard feedback on this is what you're designing, this is the change that we want you to make. If you're an Oak9 community user, then you can actually publish that reference architecture to Oak9. And what the community edition manages is we will then manage all of the developer integrations. So we will give visibility into that architecture as early as when that developer is building it in their IDE. As they commit to their code repositories, you can get visibility into that architecture at that lifecycle stage. As the pipeline kicks off, you can get visibility at that stage, and then you deploy to dev, test stage. And so at each stage in your lifecycle journey, you can then get visibility into that architecture and automatically assess against your reference architectures based on the usage guidelines that you've provided. So what I'm going to do now is just shift to a demo, and we've designed this. One of the core guiding principles for us has been mean time to dopamine. How quickly can you get started and get value out of this? And so very quickly, I'll be able to show you what this looks like. So if you wanted to get started with Tython, all you have to do is, and of course, there it is. All right. You can install the CLI. If you're a Mac user, you can use Brew. Homebrew, if you're Windows, Linux, we have an approach, and you can download the binary from our releases page. And then you download our Python framework, and you'll have to obviously have a Python environment on your local machine. Once you have that, it's really that simple. And I'll shift to an example of a blueprint that I've built. It's very simple and straightforward to illustrate some of the points. And so really, let's start with the CLI, right? So CLI has a number of different commands that you can use. You can initialize this, and we'll give you kind of the first hello world example that you can build off of with all of the documentation that goes along with it. You can apply this particular blueprint to a solution architecture that has already been integrated with, and we have an understanding of what that solution architecture is, so you can apply this blueprint to that architecture, and I'll walk you through that use case. So what does the framework look like? So the Python framework, and just show of hands, like how many folks here are familiar with Python? Awesome, yeah. So majority of the audience. This is why we started with Python. We did a lot of surveys, and security engineers really like Python. So what I've done here is I've built a blueprint that is really focused on assessing the key management architecture and very specific properties of that key management architecture. And I can extend this to cover really all of the key management requirements that I may have, right? Key rotation, key length, key algorithm, key backup, key escrow, access control for the key. So you can really assess the entire gamut of key management lifecycle requirements if you wanted. I've built some very specific tailored use cases that my team doesn't actually support today because these are very contextual to your environment. And so the only thing you have to do in this framework is you define your own blueprint class, and you inherit from ours. So this is the part of the abstraction where we handle all the nitty-gritty details on the back end, keeps things very simple for you. And then you can define your own validation checks to validate specific properties of that architecture. And so what that looks like is the only thing you have to do is you inherit from our blueprint class, and you have to adhere to this interface. You have to have a validate method that we will call to then validate an arbitrary solution architecture against it. And here what I'm doing is I'm finding all of the key management service instances in this particular solution architecture that at this point I have no idea what the solution architecture is, right? And that's intentional. I'm going to get a list of key management services. I'm going to then assess each of those key management services. And in this particular blueprint, I have 3 properties that I'm assessing for. I want to validate that each key is tagged with an owner tag. So in my organization at Acorn Corp, I want to make sure that every key has a key owner, and so I know who's responsible for the key lifecycle of that key. I want to make sure that, when a key is deleted, that it is only retained for a certain period of time before it is completely destroyed and never recoverable. And then lastly, I want to validate what algorithms are being used for signing, right? So these are kind of disparate use cases, but really to highlight how easy it is to get started with this. And so the only thing we need to return is then some findings for that developer is here's what we found, here's the issues, and here's what we want to report on. And so I'll walk you through that tagging use case, right? So this is, once again, a simple use case where I want to assign an owner tag to every key that is being issued from this key management service. And so we'll check to see, okay, well, these are all strongly typed objects. So going back to that abstraction design decisions that I was talking about, right? So these are strongly typed objects where this is the property that I'm looking for. I want to assess tags. And tags show up as a key value pair. And if tags are not defined, or key owner is not one of the keys in the tags, then I want to throw a finding for that developer. Here's the resource that had this issue. Here's the metadata associated with that resource so we can validate and then also remediate. And I'll show you what that looks like. Here's my internal requirement. And let's make this a key management requirement. In my organization, right, this is a high issue or a critical issue. And so I want to make this a critical issue so that that developer prioritizes fixing this issue. And here's the description for that developer, and I'll give it. I'll update the description, and this is what I want the developer to see when I find this issue in their architecture. And that's it. I have built this blueprint. I've updated it. Now I'm going to apply it to a solution architecture. And so the prerequisites here are that I've set up a project within the Oak 9 Community Edition so that I can integrate into this developer's code repository and get visibility into the architecture that they are building. And so they may have just made a code commit, right? We can trigger on a number of different things, but in this case, right, I'm manually triggering a validation. And I'll show you what that repo looks like. So we have a purposefully vulnerable AWS repo. And this AWS architecture is pretty typical. It's defined in Terraform. You would find a lot of these feature capabilities within your organization if you're AWS users, right? It's using an API gateway that has microservices on ECS and so Fargate and EKS. There's a key management service that's being used, and pretty modular, well-defined Terraform here. And if you look at what we just did, right, and I'll refresh this. So any minute now, we're going to create a new PR here. And it's going to come in as a PR for that developer. So we scanned this code. We found all of the key management services within this code. We identified where those specific we measured those specific architectural properties that we cared about. And we want to report on those properties and give this developer feedback. And so, yep. So they just came in. And so we grouped those design gaps. This is how I've configured it. So I'm grouping these by critical, high, and moderate. And here's all the critical gaps. And what's happening here is we are running both the Tython blueprint that I just wrote, as well as, because this is integrated into our community edition, we're actually using the blueprints that my team built. And so they're both assessing this architecture, and my team focuses on kind of industry best practices, whereas the use cases that I was showing you were more custom and more specific to an organization. And so now we're merging the feedback from both of those, creating a PR for this developer. And what it shows up as is a code change. So we found a number of issues, and I'm going to search for, right, RSA talk, RSA demo, right. So we found this key owner. We found that here's a key that's being defined. It doesn't have all of the right tags that we want to see with that key. So very early in the life cycle, we can start giving this developer feedback to say, hey, you need to have this owner tag before you actually deploy this in the dev environment. So across the board, then we're finding a number of issues, and a lot of these are coming from the Oak 9 blueprints, but a lot of these are also coming from the blueprint that we just wrote. So here's another key that we found. Same issue. We're also looking at, if I go to the high issue, one of the other checks that I was making was deletion window. And so if I look at deletion, we went and found that the deletion window in days was 10 days. We changed that to 5. So we automatically remediated that issue for the developer. And really, what this allows the developer to do is operate on the functional capabilities of their product without worrying about all of the nitty-gritty security details. And if they're concerned about, well, why is this 5, right, they can go and look at the reference architecture itself. All right. So let me shift back to the presentation. All right. So what does this look like in operation, right? having the ability to write these reference architectures in a language like Python allows you to really build within your own organization, your own tooling. It allows you to build modular code, modular reference architectures, build your own abstractions that are useful to your teams. And I want to walk you through a case study where, with the alpha version of this, right, we worked with a large fintech to really understand, well, how is this going to play in their environment? How are security engineers going to respond to this? And they had some of the same challenges that I talked about earlier. Security teams weren't able to keep up. And really what we saw is by building design patterns and really automating the validation of the design, what we were able to measure is that within the organization, they were able to cut the validation of that design by 50%, because for most common things, they were able to build reference architectures and automatically validate that. And then the conversations they needed to have with the development teams were much more focused, much more productive, and much more collaborative. And so what I'm going to leave us with is some of the key challenges that we're still solving for, and where we want the community to come join us and help address these challenges. So one of the key challenges is shared security infrastructure. So if we think about the world in terms of applications and projects, then what happens when two applications share the same infrastructure? What happens when your cafeteria menu and your most business critical application relies on the same key management service to issue keys and manage keys? Then the requirements for the cafeteria menu are slightly different than the requirements for your business critical application. How do we make sure that we give the right feedback to the developer, knowing that there are other applications that actually rely on the same shared infrastructure that they're relying on? And so the decisions that they make may impact other applications. The other kind of major challenge is, well, how do we know what is the right design pattern? So we're building a usage guidelines framework that allows us to understand better what are the usage guidelines, where do you want us to apply this reference architecture. But in the end, right, in large complex environments, how do we actually find the patterns that should apply? And there may be more than 10 different patterns that apply to an architecture like this. So how do we actually match the right patterns? And we have some amazing work that we're doing in this space that we're releasing pretty shortly. But this is where we want to really get some more community feedback is, how do you think about this in your workflows today? And then lastly, security is an emergent property of a large complex system. And so when we take a large complex architecture, what meaningful statement can you make about that large architecture if you validated various patterns within that architecture? But then what is the meaningful statement you can give back to the business to say, hey, we assessed this architecture, here's what we can confidently say about this architecture, knowing what we assessed. And that is the hardest problem here, and that is the problem that we are solving over the rest of this year. So I'll wrap up, and hopefully, everyone found this useful. But really, some of the takeaways here are, I think everyone here understands that cloud architectures are just growing in complexity and scale. We need to embrace automation. Automation is the only way that security engineering can scale to this problem. And we really need to focus on preventative security and really validate the security design as opposed to being reactive after the fact. And it's not enough just to validate configurations. We need to think about the problem in terms of the architecture, in terms of the design that we want to actually enable within the organization that we want development teams to follow. And then lastly, we have this open source project. We would love for more users to collaborate and join our community at tython.io. We have a Discord. Ask questions. Right now, we've released an early beta. Lots of changes are happening over the coming weeks, but we would love for you to try it out. Give us some feedback, what works, what doesn't work. We have a team dedicated to supporting this, but we'd love the community to come in and collaborate as well. And bring your use cases to us, help us understand what are the challenges that you want to solve within your organization, and we'll continue iterating and building on top of this.